This is going to be a video on multiplying polynomials. At this point, you should know how to add polynomials and subtract polynomials, which is another word for just kind of combining like terms. But for those ones, sometimes you just have the brackets, so might want to review that. This video is just on multiplying. So in order to begin, I sort of have to clarify with you how I sort of define my algebra tiles. So I'm going to show you both methods. First one with algebra tiles and one without algebra tiles. So here I have three different shapes here, three different shapes here. The ones that I have colored are my positive ones, and the ones that are just white or absence of color, that's my negative ones. Notice that this looks like a big square. Well, that's going to be my square with exponent 2. This doesn't have to be x. It can be p's, can be n's, can be t's, can be any letter as long as it has a square. So this one is my negative square. And the next one, the rectangular shape, this is my variable. So this is my negative one, this is my positive one. And the little blocks, I'm sure you guys know that these ones are your constants. So this is +1, -1. Another thing that you have to know is this is multiplying. So this rule has to apply. That means that your positive times a positive has to be positive. Negative times a negative is positive. Positive times a negative is a negative, and negative times a positive is a negative. So this only applies if they're multiplying, 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 multiplying together, or dividing them together. So if you have something like an add or subtract, this rule doesn't apply. So make sure you have that is clear for you. So moving on, let's go check out the first example. Here it is, 4x times 2x. In order to set this up with algebra tiles, you have to set up a sort of like a little multiplying grid. So this is the grid that I have, and I have laid out my algebra tiles already. So you can see that for the 4x, I have laid them out at the top. So these ones are my x's. I have 4 of them, so here's at the top. And my 2x, I'm going to put the other term on the side. So this is my x and x. Basically, how you want to use this is you're going to try to figure out what shape goes in here. So you have an x and an x. If these ones were to combine, out of all these algebra shapes, which one can go in? Well, you can see that it looks like this, so there's a square. And then the next one is going to be your next box, so this is going to be the next one. That means it's from here to there and there to there. Which shape can fill in that little space? Well, this square. So as you fill all of these ones in, you're going to see all these ones match up, right? And after all of this, and these ones are green because positive times positive is positive. You can calculate. I have 1, 2, 3, 4, 5, 6, 7, 8. So that's positive 8. And what do they represent? X squared. That's your answer. That's with algebra tiles. If you want to look at this algebraically, you're going to do this. You're going to multiply the coefficients, the numbers. 4 times 2 is 8. And x times x, remember this is from your power and exponent law. So this is going to be x, and you're going to add these invisible ones together, which adds to x squared. That's how you do it without algebra tiles. This algebraically takes a little bit of practice. Algebra tiles does take a little bit more time, but you can always see how you got your answer. So let's try another example. You have negative 2m, 2m plus 3. So we want to set this up by having a little grid like this, right? So you can have negative 2m. Since this is negative, I'm going to take 2 of these guys, so that's negative 2m. And then I have positive 2m, so I'm going to take this, and I need to rotate it on its side, so that's 1. And I'm going to take another one and rotate it on the side. Those are my positive 2m. And then I have plus 3. So there's 1 and 2 and 3. So basically, now we would need to find the gap. So here's one gap. So we're just doing the outline of these two. So that's another one, and here's another one, another one. But which one do I take, the green one or the white one? Well, since this is a negative times a positive, I'm going to take a negative one, because negative times a positive is a negative. So those are my squares. The next part is, well, how do I fill this one in? This shape goes to here, right, at the top, and then here's the bottom, and this is the width of it from this one. So then I have to look at the rectangular shape. So which one am I getting? Negative times a positive is a negative, so I grab this one. So after practice, you should be able to see that it's really easy to use these algebra tiles. And if you have the algebra tiles in front of you without sort of cutting them out, it's pretty easy. So then this is not the answer yet. You have to translate this into your x's. So you have 1x squared, negative 2, 3, 4. So that's negative 4x squared. And then you have 1, 2, 3, 4, 5, 6, which is negative 6x, because these are all negatives. So let's see if we got the answer right here. Exactly the same. And if you wanted to do this algebraically, here's the method. You're going to distribute this one to that one, and then this one to the last one. So negative 2m times 2m. So let's look at the coefficients first. Negative 2 times 2 is negative 4. M times m is m squared. So that's done for the first distribution. The second distribution involves this positive sign as well. So negative 2m times 3. So negative 2 times 3 is negative 6. And then m doesn't have anything to multiply to, so it's just m. So then this is exactly what we have here, except that I forgot to change my x to m because I misread. So double check your answer. Let's try a third one. Negative 3n times n minus 5. So you can see that I have laid out my algebra tiles here. And then here's my positive n and my negative 5s. And you can see that by filling this with algebra tiles, you can quickly see what your answer is. This way is a good way in the beginning, but after a while it does take a lot of time, and if you can move on to using the algebraic version, then go ahead. I think that's a great idea. And let me just fill these ones in, and I'm sure you can already see the answer after I fill all these ones in. Wow! See, you can see that this one does take a long time using my little pen and moving this back and forth, back and forth. Okay, so finally, count all these. These are all squares, negative squares, so I have negative 3n squared. Make sure I have the right variable, and I have 1, 2, 3, 4, 5, and I have 3 rows of that. That's 15, so that's plus 15n. So let's look at if we were to do this algebraically without algebra tiles. So here's the method. Distribute. First one to the first one to the last one. So negative 3n times n. So that's negative 3n squared. Negative 3 times negative 5 is positive 15n. Okay, so make sure you can understand the difference between these two. If I am going too fast, you can always pause the video and just go back. Okay, you don't have to listen to me and follow along the whole way. Okay, last thing is I always get these questions of two different variables, like 3m times 4n. Well, the thing is, 3m is like 3 rhinos times 4 zebras. And when you multiply this together, you're not going to get a zebra rhino, because this is out of the question, so this is wrong. So how do we do this? Well, since these are completely different things, rhinos and zebra, you're not going to have a mixture or hybrid of them. You're just going to have both of them multiplied to each other like they're friends. And 3 times 4 is your 12. So instead of here, we're going to look at these letters. 3 times 4, your coefficients, that's 12. M and N can't do anything, so that's just going to be M, N. And that's it. So hopefully this video was a little bit longer. Hopefully it was enough because I provided 3 examples. And next one's going to be dividing polynomials. So see you then.